Hello and welcome back to another episode of Getting into Git Oxide. And welcome back, Sydney.
Hello.
And yes, we are back with our favorite, the nearly never-ending describe. And there are 3 to-dos left after the last session that gave us this wonderful custom error with this error, and it was fun and good. Oh, put in. And now one of these to-dos is the easiest one, and I think it might be this one. Figure out if not having a date is a hard error, or what does Git do? That's the question.
So do we just test it out with a, I don't know, with a repository where we delete the dates and see what Git does? Or do you want to check the code?
Actually, in order to trigger this, you have to delete the whole committer. Like you have to have a commit without committer. And that's something that with Git Oxide, I mean, Git Oxide doesn't even let you do that. You can, I mean, not on the level where you usually work, but you can theoretically manufacture a commit that does not have a committer. And you can write that with plumbing capabilities, you can. But I don't even know where that happens. So I wouldn't actually know how to test that except for writing a program that actually creates a commit like this. But maybe just look into the code. That's what I would do. I find that easier. So I think, and just see what happens when Git doesn't find a committer. Does it die? Yeah, I take your best guess. Does it die or does it ignore it? Right now we ignore it. What do you think?
I'm guessing it would ignore it.
Okay, good. Then I'm guessing it would die. And here we are in the scribe. Where does the traversal happen? We pop commit. Okay, where do we push commits? That's the parents. There. Here we traverse parents. And then we insert by date. So there it would have to get the commit date. And it just seems to have a date. And it's just always there. Okay. So where's that thing parsed then? Parse commit here. And there's no error handling, no obvious error handling. So if it does anything, it dies. Otherwise, it ignores. Repo parse commit. Okay. Can't parse it gently. Don't be too rough with the poor commit. Do that internally, behind closed doors. Nobody should see what gentle commit parsing actually means. And quiet on missing. That's interesting. So that's related to shallow kind of things, and also related to filtering. You can also filter objects and basically say, give me a pack that doesn't have blobs, to save even more time when downloading things. So Git has a cool ton of features to get smaller packs and only download the fewest amount of objects possible. Use commit graph. Oh, that's also cool. Because we do have a commit graph crate that allows you to parse that, basically cache of the commit graph to traverse it more quickly. But currently our own traversal does not use commit graphs. So yeah, this should not matter, but where does it happen? Yeah, so commit graph you can ignore. Read object file gives us the buffer. Okay, so where's the buffer being passed? Here. And there's return error. Save commit buffer. Interesting. A global flag that says save or not save. Okay, I assume by default is on. So if parsing doesn't work, no, if parsing, yeah,
if it works, right? Yeah.
If it works, not is good in C world. I'm always struggling with this. I really can't imagine. Somehow, 0 is a good exit code. And then it sets the buffer. It's interesting. I never actually looked at this. A buffer slab. Okay. Ah, that's a, I don't know what is that. No, what is this? Is this nothing? Or is this a declaration of a struct that is defined somewhere else? Ah.
Oh yeah, we had that before.
It's a declaration, right? Because here it only knows the pointer, so it doesn't need to know the size of the object. So that doesn't really help. Okay, it stores the, it gets a buffer slab for the commit, has a commit buffer, and then just saves that. Okay, but that's already the happy case, right? So this means in the unhappy case, it doesn't save the buffer. And it just returns the error code, which is ignored for us. So this item, that's something that it probably sets, huh? So these values there are on the item. So now we have to check where item is passed. So here it's possibly changed and here it's possibly changed. Compare that to Rust, where it's super obvious where something is changed.
Sure.
And here it's like, well, maybe there, maybe in parsing, maybe parsing changes something. Has to write the data somewhere. Maybe set commit buffer. And that just seems to save the buffer itself, the backing buffer.
Mm-hmm.
But I would assume that during parsing, it writes data here. So here it should probably write the time. Oh, searching for time did not yield a result. Okay, so maybe that's hidden somewhere. So you see here it parses the tree. It parses that really, really by hand. Like it doesn't say give me the header for the tree because it's basically this file here. So here, and it kind of does that by hand. It doesn't seem to have functions for that. Lookup commit graph. I don't know what that is, something special. Here it parses parents. Where do you parse your authors? Ah, parse commit date.
Yeah.
That's more like it. And it does assign it no matter what. So maybe this aborts. Author. Look, it returns null. So if something can't be parsed, returns null. Return null, return null. Okay.
So it's like a default then. It basically ignores it, right?
It ignores it and it sets the default, I presume. Yeah. Yeah, return null. That's the timestamp. Okay, got it. So now we know. That's that. This is the answer. So the answer here is we do the right thing. Just assume null.
Yeah, we already default. Cool.
Yeah. Cool. Even though we do know if it worked or not, whereas Git just, you know, if there's a null, it probably didn't work because 1970, nobody created a commit. Makes sense, right? It's okay. But yeah, if you want to have a test repository with lots of commits at epoch null, Git might be confused because that's an error code. But probably not. Probably nobody checks for that. Okay, cool. Now, maybe you can figure out what gave up on commit does, whatever the easiest is, because one is finish computation, and then is gave up on commit.
Yeah, the gave up seems a little bit easier, I think.
Yeah, even though I remember something vaguely that it kind of leads to finish computation no matter what. But yeah, let's see. Maybe we are lucky. Gave up on commit list insert by date. Okay, we added to the list and reduce the scene commits by 1. We can do that. And then it leads to finish computation, because that list is then picked up there, and that gave up on commit is contributing to that finish computation. Yeah, I think that's it. Oh no, there's another point here, but that's debug. Okay, so it's really just this. And I don't know about testing this, to be honest, but let's see. Maybe we find a way. Okay. So if we find a commit, sorry, if we find a tag or whatever name that is at this commit, but we can't use it because we are above max candidates, then we will trigger this. So my first idea would be to make this configurable so that we don't need 64 candidates to trigger this code, but can set it to 0 even, you know, or to, I don't know, 0 probably makes no sense, but 1. But even 0, why not? It's a number, it can be 0, so we can just make it 0. And then we should get in here and should be able to figure out what happens, which might be something like I could not find anything, which probably also is happening. No, it's not the same. Yeah, that would be my intuition. What do you think about that?
I think so too, yeah. I mean, otherwise it's not easy to test this, yeah. Just make it run into this case and then see if we can find something to see what happens.
Okay, cool. Let's do that. Let's do that. Describe mod. So you see, by just following the same structure, I know, okay, I have to look into the scribe. It's not about formatting here, so definitely in mod. And then I should be right at the spot. Option none if no tag found. Then special handling. I don't know really how to phrase this. I don't know how this contributes really. Like, I think this just helps to calculate the proper commit count. That would be my idea about it, so that it always gets the right number. So this would probably mean that we can just try to run this and limit it and see what number we get with a known name. So maybe a better test would be the one for typical use cases where we actually have names here. Where's my name? Yeah, that's already an exact match. I think it's more like this one here, where we find something later, and then we have to set the max number to a small one so that it kind of stops iterate. It runs into this gave up on case with the next tag it finds. So it's this. So that's our sample repo. And then we can do this. Oh, okay, I like that. I like that way better. Thank you, onefetch. You were the trigger. It's like, do I want people to write this code? Nah, not really. It's going to be repeated. You know, it's always like, how much API surface do you want to have? But when it comes to like the current API, I think it makes sense and you can do it. And it, you know, from a Git perspective, it makes perfect sense to get the head and then you deal with the head and figure things out from there. But from an API and ease of use perspective, you really want people to have the common stuff come to you, you know, fly to you, fly into your hands. Just do it. Everybody needs to start there. So it's a nice motivation to make that easy. Very easy. Okay, cool. Here we are. Git describe vector. So as fourth argument, like I'm wondering, should there be an option struct or should there be just another number as a parameter? Because that number is a loose number, right? So we could just type 1 here now, and that would then be the max count. We have no, like this is how calls look like then. So I'm thinking I don't like it too much. The alternative, I also don't want to overthink it, don't get me wrong, but these loose numbers, they're usually not so great. Alternatively, it's easy and straightforward to put a borrowed hash map into an option and into an option struct, and then have options passed around that then has a name. And I think that will make this better. So I feel like having an option struct with 2 fields then is worth it. So we are in describe error, describe options, put that there. It's not liking it. Yeah. Oh yeah, it's not enum, it's a struct. Okay. I don't know why it's still highlighted like this. Should have camel case? Okay, it is camel case last time I checked. Okay. Derive clone is usually not a bad idea. Right now it would also have to derive copy because that's just a reference. And we are going to add a number, so that's all copy. If all fields inside are copy, you probably want to implement copy on it, at least clone. And usually also all these other things like compare and debug and so on, but usually I leave it out. I don't know if it's a good thing because people probably want to debug this. I'm not really great with derive yet because I tend to save it, even though I know I should probably add it. Because what do I know? Are people going to use it? You know, why would I give them the basics? I actually just recently had just yesterday or so had a PR that added a bunch of derives for one type because they needed that. So yeah, maybe I learned from this, huh?
That is just a standard set of, yeah. So everyone's happy.
And hash, not to forget. Ideally, there's like everything that you can that is standard, do it. You know, I think this I would do. Then I would not think about it, but you know, I think this is something for proc macro. Like if I would do a proc macro, it would probably be this one. But not like proc macros are now. Like if I have to pull in a whole dependency chain of stuff that takes 10 more seconds to compile, I would not want to write a proc macro like this. I think that's holding me back. All right. Then we have max candidates. Like here. Okay. And can put that in here. Options. Oh, look, it uses git describe options, which is closest. I think I might have gotten an update. Syntax error? Why? This should be... Oh yeah, now it caught up, but it should format it. Ah yeah. Now it will format it. Right. Now we're talking.
Oh, so that's just destructuring the input parameters, basically.
Yes, it destructures it right in the signature of the method, which is really, really useful. It's just super nice to use that way, because previously you would declare options here and you would possibly do a let options be options, blah, and then you kind of have a lot of extra lines.
Yeah.
And why not use the totally useless method declaration part here to also destructure in the same moment? Very neat. Does TypeScript do that, by the way? Can it do that?
I think it can. Yeah. Actually, it can.
Yes, I think so too. I think I vaguely remember this. I think in React you can do that all the time, like with put the
exactly.
options to structuring there. Yeah, it's amazing that a kind of strongly typed language like Rust does this kind of stuff. Huh? You would kind of attribute that fancy stuff to TypeScript and the likes, but and Elm, but no, Rust can do it too. Right, now a bunch of tests will fail. Oh yeah, we've got a lifetime. Oh, back to the lifetime. I forgot, I was rushing. Here, do you see the potential issue? That's at least worth talking about, just to make sure it's not an issue.
I'm not sure.
Here we have two references. We have a reference to the hash map and a reference to the contents, to part of the contents of the hash map. And right now we only give it one lifetime, which can be an issue under certain circumstances, because now it takes the smallest of both lifetimes as the lifetime of the whole thing. So even though this content here might be borrowed from something that lives longer than the actual hash map, it will look like it only lives as long as the hash map because of the -a. So if we would return anything from that hash map as part of our return value, then the lifetime on that would be wrong because it would be too small. And the caller of our method, describe, would then suffer from lifetime warnings, even though this stuff lives long enough. But we kind of hide that now. But if you don't return anything that is in that hash map, you wouldn't have to care.
So then it should be fine. Okay.
Then it should be fine. If you just use it, cool. So do we return something from our hash map? We do have an outcome here with A. And A. Suspicious, yeah. A comes from here, so the value is exactly something we return. So that's the answer. So A and then name. That's the name. 2 lifetimes, and we need both to be able to do the right thing. And now we have the Rust 2018 idioms, because we do have to clarify which lifetimes we are providing here. And here we have A, but we know A is actually the name.
Yeah.
And now this is a bit easier to assign. I don't know what the first one is, but I know the second one is name. And now we just match this here, right? So that's why you sometimes assign names to these lifetimes, so that it's a bit easier to remember what is what. Okay, so what's the first lifetime? Like, which name do we assign to the first lifetime, which is the hash map itself?
I'm not sure.
Which question could I ask to guide you there? Like, if you don't know the lifetime, or if you say, Rust, you do it, I don't want to say.
Oh, okay. With the underscore, basically, you just...
Yes.
say do it automatically.
Do it automatically.
I don't even know what it's called.
Yeah, good question. The underscore lifetime. So it's general good piece of advice. Like if you don't know, try not to specify. Try to let the Rust compiler infer it for you. It's just that here, because of the Rust 2018 idioms, we do have to specify something. But this is infer, right? Similar to types. You can also write, when you collect something into a vector, I always use underscore because it should just infer the contents of the vector. And this is why infer lifetime is the same thing.
That's very helpful. So you don't actually have to declare another lifetime at the top, and then it just does it automatically. Yeah.
Yeah. By that rule, you can do this too. And you can actually. And that's actually what's happening here. This, if you write it out, it's this. And if you want to, you can have names for that too. You can say A, B, and then assign names. As long as these are distinct, you get the same result. And I would expect IntelliJ to tell me that it can elite the lifetimes because they don't have to be specified, but it doesn't. Okay, but that's all there is, and I think once you've understood this, you can deal with lifetimes much better. Okay, then it wants equality as well. Trade bound. Oh yeah, or does not implemented for the hash map. Equal is not implemented. Hash is not implemented. Okay. Oh. This does not work anymore. But should it work? It should work. We should have a default for these options. Oh no, we can't. We can't anymore. Oh yes, we can. We can just have an empty set.
Just empty.
But no, we can't, because we can't just make. Oh yes. Can we get an empty set statically? That's the thing. We can't just make up a reference to a hash map that is empty. We need the actual hash map. So we need to initialize a hash map. And I wonder if these can be const initialized. And I don't know if that's possible. Let's look. Hash map. Can I const initialize you? Does it tell me what's const here? Const. There's a const. What is this? Const from. Okay, there's just one. And that is a different thing. So it looks like I can't const initialize this, which means I can't easily get a static empty hash map. And static means, yeah, it's initialized at program start. Yeah, can't do it. If we would own that hash map, that would work, but not like this. We can potentially make it easy, and let me try one thing. Can I do this? Can I just write it? I'm sometimes overthinking things. Hashy the hash map. Hash map. Let's make a hash set easier. Can I const initialize this? Oh, does it work, really? Yeah, see, only constant functions or tuple structs. So as long as there's no hash set, there's a hash set new, but I think that's also not, it's not constant here. Have you seen these const functions?
I have, yeah.
Const methods, okay. This is what you want for the static context, but hash set didn't catch up for that yet. I would assume that this can be const initialized because ultimately probably this does not allocate unless there's actually something in it. But maybe I'm wrong about this. Bucket mask.
This is about now knowing the size, right? At compile time, basically.
Yeah.
Or at, yeah.
Actually knowing, having a thing working, yeah, knowing what it's going to be at compile time.
Yeah.
And then you have to evaluate the code essentially. But look at this here, there's this control, and that's the non-null pointer. Oh no, wait. I think non-null, that's assigning, that's actually the padding bytes. So that's not a pointer. Alloc A. So it needs an allocator. And I think because it needs an allocator, that is only known at runtime. It can't static initialize it because an allocator does not exist early enough. So yeah. That explains. Yeah, so long story short, we do not get a default for this one unless we own the hash map. Is it okay to own the hash map? Could be the next question. And honestly, like people are probably gonna create the hash map just for us. So we could make it so. I mean, the names, they're not necessarily owned. And these are copy. These are cheap. But then again, if they give us the hash map, we can return it as part of our outcome. We have that here. We can just return the names for people to reuse them because people could reasonably make multiple requests against the same set of names. So I wouldn't want them to lose it, but then
yeah.
How likely is it that we lose their names because we have an error? We have errors for not finding things, which is now, yeah, that's kind of rare because now it's even harder to abort even on a shallow tree, and for decode errors. So it's kind of rare. Like decode errors, you really have, this is an invalid object.
Yeah, it's not gonna happen quickly.
So I'd even say I'd be willing to let people lose their, like if the scribe fails, you just want to continue and keep going or want to abort because it really should not fail. So I think aborting is okay. Yeah, so for now I'd pivot towards owning this hash map and returning it. Hash set, name set. Name by OID. Okay. I thought it, wow, really has issues. I have to restart it. Super slow. Okay, cool. So let's own this thing. One lifetime less. That helps. Now all the talk about lifetimes. Not for nothing, of course. It's always good to know more.
But you still have to declare it here, even if it's only one?
Yes. Any lifetime has to be declared. Unless it's inferred, but it's not inferable here because we really have to show where it's going. And now we can do default, and it's just, now it's not automatic because max candidate should be something reasonable. And we just set this to something non-null, I suppose. Yeah, let's just set it to something reasonable. Okay. Max candidates. We just pull this here, private to us. Max candidates. And then the rest supposed to be just, no, I can't do that because that would call us recursively. It's tempting to say, hey, and here's the default implementation. But no, now we have to do everything.
Why would that be recursive?
Because default, this just infers the type of what you need and calls default on the type, since our type is options and we are implementing default here. Yep, I've done that. I've learned that the hardware way. Rust warns you though. Rust tells you right away this is a recursive call, but it will do it anyway. And then the Stack Overflow that you see is not the one in your browser. Yeah. So yeah, that's the default here. Cool. And all that fuzz for fixing the tests. Oh yeah. Git repository index entry flags. No. We have our custom flags here somewhere, huh? Yeah. I wonder where that is. Is this here? It's in the function crate. And just take it out of here. That should be okay. And then bring that down. Okay, now we have a good default. And finally, no flex is gone from here, but we can import it. Same with flex. Should press F2 to jump to the next error. Okay, cool. Now back to the tests. Yeah, that's not copy anymore. Fair enough. And yeah, it's a bit poor, huh? That IntelliJ can't focus my editor on what I see because it doesn't know that it's covered. It's kind of, it allows me to work underneath that thing, which is kind of always useless. Like, I don't know why I would want to do that, you know? I want to have an undock, but it's still, it's not just overlapping like this. I don't know. Anyway.
You can't have it all.
You can't have it all. Write an editor yourself, Mr. Byron, and then you can see how hard it is to do that. That is okay. I don't have to write an editor. I'm just the customer. I can always want more. And you delight me, do you? That's why. Okay, anyway, let's try to get options ready here. Should be easier now. Should feel a bit better with the name. Yeah, actually, describe options. Name by OID. Look at found it right away. Neat. And now max candidates 1. And that's all we wanted. Plus, of course, kind of return this in our outcome, which definitely adds another. Oh no, it does not. Look, that's the name. We know.
Yeah, it's the same thing already.
Yeah, cool. does change nothing for that particular type. Neat. Okay, here you go. Take your map back. Name by OID. We destructured that already. Down here, once again, name by OID. The stuff we are doing here is something you dream of in C++. And you don't even dare to dream of it in C, because you just don't. It's really, it's crazy cool stuff. I mean, it's kind of standard in Rust, but it's just unthinkable, really, to do that safely. It's so cool. Hash, oh yeah, we lose a lot of capabilities here. Equality, we lose. Partial equality, we lose. I hope tests don't break down now. And oh, right, this outcome. But we can just default this. Oh, of course we don't have a default for outcome, so now we have to make up a map here. Okay. And now outcome can't be compared anymore. See, I knew something would break. Can't find anything if there's no candidate. Yeah. What kind of type is this? Is this a result option? Yeah, it's a result option. So we can probably just do is none, huh? And that will neatly bypass this issue. And here we want to have and describe options, name map, and then default, because we don't actually want to deal with the next candidates. Oh yeah, this one again. Oh, look, and here we do actually compare that entirely.
Yeah.
Oh, and why can I not compare that? Ah, because the hashmap doesn't allow this comparison. That's a bit annoying.
Yeah.
But I guess since nobody uses it like this, it's really just a test which enjoyed this. We can probably just do it field by field. Oi. And then ID is commit ID, and lastly that is now. Phew, getting there. That's the last of them. Describe options. Here we get the name map. Yeah, I started to copy paste too early. Oh yeah, and then default. No, not here. Here. Okay. And the same issue. Ah. Now res.name is name. And maybe the text I put here in the first one, then the rest can be copy paste, which it seems to be anyway. Depth 3 this time. All right. Cool. Now please, there we go. Just a bunch of unused things. Cool, I could bring it back up with Command 4. That's pleasant. Next candidates never used. That makes sense.
Oh, you're still comparing it to the the constant.
Thank you, Rust. You're perfectly right. That's not intended. Next candidate. And now this import isn't needed anymore. And that's our test. Because we don't yet know what to expect. And we should be able to debug this. etc5 depth 2. Should that be...
Well, I gave 3.
Yeah, I think there should be more, huh? And this is probably related to finish computation. And this is how we get to use the candidate and finish computation at the same time. Okay, let's see. Depth 3. 91 EF. Here it has 2 names and it searches something else. Where's that actual example? Yeah. Oh, actually, we reuse that directly. We've got 2 candidates here, 2 names, but only 1 max candidate, and it's 2, but it should be 3. So cool, we've got something. This is it. Yeah. Let's copy paste this and formulate some tentative expectation. Which would be it finds the youngest, most recent name. It calculates the final number of commits, even though it aborted early. Yeah, should have the same outcome. We could say that, huh? That makes sense. Same thing as if you would. Yeah, cool. So now we have a failing test, and I mean, that's a wonderful outcome for today's session, I think. Lots of refactoring. It feels, to me, it feels better with the options now. And we have something to go to make work next time we try to implement finish computation, which is really what it comes down to now. And we don't really have a reason yet to do the gave up on thingy here, where we say if gave up on commit is something. Seen commits was reduced, and we added this to the queue, huh?
Exactly.
Queue
by date.
By date. Ugh. Yikes. But do we have to do that? Like, this commit was already added. We basically just put it back where it was. Yeah, look at it like this. We pop it front, and then we find something, we try to use it, and then we give up right away. So if we put it back to the front, it's right where it was. So Q
Okay.
push front. And that's should exactly be it. We don't have a test for this. Hey, what? Value assigned to scene commit that is never read. Isn't Rust smart? It's so awesome. It's true. We don't use it afterwards. And
not yet, at least, right?
Not yet. And it detects that because it's probably something unintended, and that's also awesome. Because all these small little things, they add up, and they're definitely bugs. Probably hard to find bugs. So yeah, thank you, Rust. I can't explain. I can't commend you enough. It's great to have this Rust compiler. All right, cool. But I think that's a nice end to today's session, and I'd say next week we continue that journey and finish it. That's just, that's one more to go. Finish computation to finish the scribe.
Almost there.
That's perfect. So thanks a lot for watching, and have a good day. Bye bye.
Bye bye.